mostly end in 8 or 8. And there is a table of polyatomic ions here. So the polyatomic ion names, if you look at that pink sheet, they mostly end in 8 or 8. And they really behave as if they were individual atoms. So we can treat them as though they were a single atom, even though they are several atoms which are stuck together. Okay? So we had looked yesterday at ammonium, which is different from ammonia. Ammonia is NH3 and it has no charge whatsoever, but ammonium is NH4 and it has a positive charge. So you can see there's one N and 4 H's. And just a reminder, it is one of only 2 positive polyatomic ions. So if we look on our chart, these are our common polyatomic ions. And I tend to abbreviate that as PAI, polyatomic ions. And one positive polyatomic ion is NH4+, which is ammonium. And the second one, and again, I'll print this out for those of you who are away, so you have this extra little bit here. The second one is mercury 1, but don't worry about mercury 1 too much. It's sort of a weird little critter, and I'll try and avoid it as much as possible. Okay. So here is ammonium chloride, okay, NH4Cl, but it is an ionic compound because it is made up of the NH4 plus ion and the Cl minus ion. So because it is made of ions, therefore it is an ionic compound. Yes? This is on page 36. Sorry about that, I forgot to write that up. Page 36. So what sorts of structures do ionic compounds form? They form a crystal lattice. And so what we have is, instead of having NaCl, 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 we have NH4 plus alternating with Cl minus, and NH4 plus alternating with Cl minus. What kind of attractive force do we have in between ammonium and chloride? What is the attractive force between NH4 plus and Cl minus? That is an ionic bond because we have an ion and we have a chloride ion, and therefore that attractive force between the NH4 plus and the chloride, that is an ionic bond. So none of this structural stuff really is important to the naming of it, but it does show you how you would recognize that this is an ionic compound. Even though it doesn't start with a metal, all other ionic compounds start with a metal, but ionic compounds can also start with NH4, and that will still be ionic. Here's ammonium hydroxide. Okay, and you'll notice we have NH4. And what did we do with it here to show we had two of them? We had to put it in brackets. And we put the 2 on the outside, and that means we have 2 of the H4 and the N. It applies to everything inside the brackets. Okay, so we have 2 of that entire thing. So you can see that for every one oxide, here's an oxide, we have 2 ammoniums. Yeah, and if you were to go through and count all of these, you would see that we count up 72 NH4s and only 36 oxygens, which if we do the division, that's a 2-to-1 ratio. Okay. Now, do you need to be able to draw this structure or count them up? No, you don't. You just need to be able to know that if we have a 2 on the outside of the brackets, that means there's 2 of that entire ion. Okay. If we go back to the previous page, do you see brackets here? No, there's no brackets. If we have only one of a polyatomic ion, there's no brackets. That's supposed to be an arrow. It doesn't look much like an arrow. So there's only one NH4. Therefore, there's no brackets. Okay, so that's one of the big things about polyatomic ions, is if we have more than one, we put brackets. If we don't have more than one, no brackets. Also, please do not start throwing brackets around regular ions. Like, don't throw brackets around chloride. You don't need them. We haven't used them up till now. Okay, so don't start throwing them in just because you're like, ooh, brackets, exciting, something new. I'll use them everywhere. Okay. Now here we are, we have acetate. Here's acetate. And it has sort of a funny look to it. It has a carbon, which is attached to 3 hydrogens. 1, 2, 3. And it has a second carbon, which is attached to 1, 2 oxygens. And that's why it has that sort of funny structure. We could also, if we wanted to, say C2 because there's 2 carbons, H3 because there's 3 hydrogens, and O. What would we put beside the O? We would put a 2, and it has a negative charge. Okay, but you'll most often see it like this. Now, if you see that ion, where would you look to find out its name? You would look on your pink sheet and you'd be like, okay, let's go to our pink sheet. And I see that ion here. Uh-oh, but I also see it here. That's because it has 2 different names. This is the common name. And this one is the ethanoate. Acetate's the common name. Ethanoate is the official name. You can use whichever one you want. Doesn't matter, okay? Totally up to you. Yes. Yeah. So here's acetate, and you'll notice it has a -1 charge. If we have sodium, sodium is +1, and acetate is -1, do we need more of either of them to have a neutral compound? No. So they're going to be 1 to 1. So you'll notice there's only one acetate, CH3COO. Therefore, there's no brackets. And this would be the crystal lattice structure of sodium acetate. We would go sodium, acetate, sodium acetate, sodium acetate, sodium acetate. But of course, in 3 dimensions, but I think in 3 dimensions, this would look like a horrible mess. Yes? So we're only going to look at it in 2 dimensions. Here are some other acetate compounds. And you can see when we have calcium acetate, calcium has a 2+ charge. Each of these have a -1 charge, so we need those two to give us a total of -2 to balance out the +2. And because we have 2 acetates, that means we need the brackets. If we were to write Ca CH3 COO2, that little 2 would only apply to that first oxygen there. You wouldn't be multiplying the whole thing. You would just have like 2 of those oxygens, but this little 2 applies to every single thing inside the brackets. And that's why we need those brackets. Yeah, it's the Chiku. Chiku is the acetate ion. Now we can have iron, which has a 3+ charge, and in that case we would need 1, 2, 3 negatives to balance out the 3 positives to give us a neutral compound. And again, because we have 3 acetates, we need to have brackets. And we put the 3 on the outside. But silver acetate, we're back to having just a +1 charge and a -1 charge. So we only have 1 acetate. So are there any brackets? No. What is different about the name of iron 3 acetate compared with calcium acetate and silver acetate? Yes. This one has a Roman numeral. Why does it have a Roman numeral? Calcium and silver acetate don't. It is in the gray zone. Iron is in the gray zone. Therefore, it needs a Roman numeral. Silver and calcium are not in the gray zone, so there's no Roman numeral. And what do I mean by the gray zone? Just in case you were away for that, let me just scooch back up here. On here, it's the red zone. I can't photocopy red for you, so it's gray on your paper, so we'll call it the gray zone. Iron is in the red zone, or the gray zone. And the gray zone needs, I did not leave myself enough room to write that. The gray zone needs Roman numerals. But calcium, is it in the red zone? No. Yes. Sorry, I forgot you hadn't gotten one yet. I have to tell you, I had a couple of my students from last year in Science 9, they're in grade 10 now, and they came back to visit me to get a periodic table with the gray zone on it, because they were like, oh, I need one of those. So if you're in that position next year, you're like, I would like a periodic table with the gray zone, feel free to drop by, I will have one for you, okay? Silver is also not in the gray zone, so therefore it needs no Roman numerals. I don't know why this keeps going back to the beginning, but that's okay. La 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 la. All right. So here we have two other polyatomic ions. We have carbonate and bicarbonate. What is the difference between those two substances? This one has an extra H, right? It's got an extra H. And what happens is if we take a carbonate, CO3, 2-, and we add to it a hydrogen ion, we end up with the hydrogen attached to the CO3. And you'll notice that now we have a -2 charge and a +1 charge. What do we get if we have -2 + 1? That's -1, and so we end up with 1 negative here. Okay? And one of the ways we can name that is we can take the name carbonate and we can add the word hydrogen to the front of it. So it is named hydrogen carbonate. That's the long form of the name. You can also, if you prefer, call it bicarbonate. That bi has nothing to do with the number 2 in this case, okay? Nothing to do with the number 2. So why is it important that we know about the carbonate and the bicarbonate? Well, it's sort of nice to see a pattern. If you look on your table of polyatomic ions, you can see there's a SO4 2- is sulfate. What do you think we would call HSO4-? Chat with your partner. If carbonate, if we add a hydrogen, it becomes bicarbonate or hydrogen carbonate. If we have sulfate and we add a hydrogen to it, what does its name become? There's two options. Hydrogen sulfate or bisulfate. Okay? Do you need to memorize those? No. Why don't you need to memorize them? Because they are on your sheet. Do you get to use this sheet? Yes. Every quiz, every test, you get to use this sheet. So let's go and just take a quick look on that sheet. There we go. And you'll notice that down here, because these are all listed in alphabetical order, you know, we've got A, C, D, E, all the way down to the H's. When we get to the H's, we have hydrogen carbonate, hydrogen oxalate, hydrogen sulfate, hydrogen sulfide, hydrogen sulfite. So we've just added a hydrogen onto all of those. You get to choose which name. Pick one or the other. So if I was to give you a compound like NaH2O4, you would say, okay, I have sodium. Oh, whoops, I wrote that wrong. I just shouldn't have said H2O4. I should have said HC2O4. There we go. What is the name of this guy here? So you can name that either sodium hydrogen oxalate, or you can name it sodium. And this one's kind of funny. It's got an N in the middle. Okay, I kind of like that. It's kind of fun. Binoxalate. I think they did that because bioxalate would just look really weird without a vowel in there. You get to choose, but don't use both names. We used to just have a comma in between here, like it used to just be a comma, and I would have students writing sodium hydrogen oxalate binoxalate, right? Like, and it would have this whole long thing, and I'm like, uh-oh, we need to make that so it's more clear. So choose one or the other, don't use both, okay? One or the other, but not both. And here are a bunch of carbonate compounds. We'll start by looking at those. Carbonate is 2 minus. Okay, so what this would look like is we would have a carbon with 3 oxygens attached to it, O, 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 and that would be 2 negative. And we would need 2 lithiums, Li plus and Li plus, to balance out that charge so that overall we have a neutral compound. There is only one CO3, therefore there are no brackets. Why is there no Roman numeral? Because it's not in the gray zone. Now, sometimes people, when they look at this formula, they think, oh, there's a little 3 there. Are there 3 carbonates? And the answer is no, because if you look over here, you can say, oh, look at this. I've got 1 CO3, right? There's only 1 CO3 there, right? There's not 2 CO3s, there's just 1 CO3. The 3 applies only to the oxygen, and it just makes it part of that little polyatomic ion. Similarly with barium bicarbonate, how many carbonates are there? Just 1. And then tin, if you look on your periodic table, let's go back there, tin. Oh, and by the way, if you have trouble remembering that tin is SN, have you ever seen those things where like someone opens up like a tin and this like sort of like springy snake thing jumps out? Have you ever seen those? So you can think, I have a tin, and when I open it, a snake jumps out. So tin is SN for snake. Tin snake. Oh, okay. And if you don't like that, you can just look it up. Okay, look under T on the back of your periodic table. All right. Now, tin is in the gray zone. So we actually don't know what its charge is. It's not like it's one of these ones, which are 3+, or one of these, which are 2+, or this one, which is 1+. It's not like it's one of the first columns that's +1, +2, +3. It's over here in the gray zone. We don't know what its charge is. Or do we? Do we know what the charge of tin is? We know that the charge of tin is 4. One thing I want you to watch out for, sometimes people will see that 4 and they'll think that means there's 4 tins. And they'll write SN4 CO3. No. Oh, look, I even gave it an angry eyebrow. Oh, except for I've erased it now. That's not a 4. It doesn't tell you the number of atoms. It tells you the charge. Okay, so we have that. So we have a 4+. And because carbonate is 2-, we need 2 of them. 2 + 2 is 4. And so now we have a 4+ and we have a 4-, and that's all balanced out. So we do put the brackets around it because now we have more than 1, and we put the 2 on the outside, saying that we have 2 of them. So that's tin 4 carbonate. All right. I think that's enough of this for now. We're just going to go into 4.2b, because for those of you who are on quiz 5, this is going to get you into actually being able to write things. So we're actually going to go to page 45. We're going to skip page 44, and we're just going to go straight to page 45. Many times, people look at compounds with polyatomic ions and they look at it and they're like, I have Al, that's aluminum. And then I have a P, which is phosphorus. So they'll write like phosphide oxide. And that would be wrong. You do not name each individual element. These are ionic compounds. There should be one cation and one anion. So you're only going to have two names only. The only exception is if your ion is hydrogen carbonate, then you can have a hydrogen carbonate. We'll talk about that in a bit. So part of the trick is saying, who is the cation? It's either going to be a metal, which is the positive ion, or it's going to be NH4, which is also the positive ion. If it's not metal and it's not NH4, then you probably have a covalent compound, a molecular compound. So if we look at KNO2, potassium is the metal. So that's your cation. Magnesium is the metal. So that's your cation. NH4, that's the one you have to watch out for. That's the new one. NH4 is the cation. Once you've found your cation, everything else is the anion. I don't care if it goes on for like 3 paragraphs. Everything else is one single anion, just one type of anion. So if we look here, we've got all the PO4, that's one anion. And if you want to know its name, where do you look? You look on your pink sheet, okay? So this is a polyatomic ion, so you're going to look on the pink sheet for the name. By the way, if you don't yet have a periodic table with a gray zone on it, if you're still using the old pink one and it doesn't have the gray zone on it, you can either color your own gray zone, or I can give you one of the yellow periodic tables that does have a gray zone, okay? Now, NH4 was our cation. That means that O is our anion. And you know how to name O as an anion, it's oxide. K is our cation, that means everything else, the NO2 is our anion. We go and we look it up and we say, what's NO2? What's NO2? There's NO2, we find it on our pink sheet and we look and it's nitrate. So we just name it nitrate. Don't mess with the names of the polyatomic ions. You don't have to change anything to I, just write the name down exactly as it is on the sheet, okay? And so I think at this point that gets you ready to do (4.2b), which is like identifying the cation and anion, and then naming them. So this would give you a start towards quiz number 5. If you want to actually do quiz number 5, you'll want to take a look at 4.2c. I'm not going to go through that today with everyone. We'll do that tomorrow. Okay, but if you want to work ahead and you need a little help, just call me over. All right, at this point, if you came in late or you didn't see this, if your name is on this board, it just means that there are quizzes that you haven't completed. I think that should say 2, but maybe I'm wrong. Anyway. there are quizzes that you haven't completed. I'll make sure that there's anything wrong here, I can change it. By the end of today, try to complete up to quiz number 4, go past. But if you don't complete up to quiz number 4, come in tomorrow during flex so I can help you get caught up to quiz number 4. Okay? Yeah, I thought so. I was like, hang on, I feel like that I wrote 1, but it should have been a 2. There we go. I didn't even write your name on the board. Yes, let's grab one of those each. There we go. So there's the 3 of them. Okay, let's get that stuff printed out. The second quiz here, I'll show you. I'll be right there. I'm just printing out the notes. I want it 2 on 1, two-sided on. Okay. Thank you. Ella, I have your quiz. So just a little spelling mistake. Sulfide. Yeah? But other than that, it looks good. Zenny. There you go. Evan. There you go, sir. Yeah. Tomas. Very nice. Just that last one. Stephen. So those two are in the gray zone, so they need Roman numerals. Okay? Yeah. I'll be right there. Thank you very much. And there's great. Mackenzie. Just in there would be great. Thank you so much. Thank you. Yes. Hema. So it was all good. You just forgot the mono on your phosphorus. So we do put mono on the second word, even though we don't put it on the first word. It does go on the second word. And you just forgot to change the ending to "ide." Okay, but mostly good. Okay. Thank you. Jude. So you should be working on quiz 5 now, right? Not playing on your phone, right? Like this is like minimum, this is getting caught up, but most people are working on quiz 5 right now, right? Yeah, so cool. All right, so Jude, where are we at here? We are at 5.5, so just a little tiny spelling mistake. That's all. So you know what you're doing. Okay, so that's good. Yep. So folks, no one should be on their phone at this point except for maybe Mackenzie. You can be on your phone. If you want to have the enriched material, you sure can. Okay, I've got it here. And the answer key is just in the regular. Thank you. Oh, I'm so sorry. I'll just get in your way. Haley, I have your quiz 3. Very nice. Haley. So I have that one for you. So this one was just a little boo-boo. You forgot to change that to "ide." And just watch out, you missed a couple of ones that were in the gray zone that would need Roman numerals. Okay? Yeah, there you go. Sky. Very nice. There you go. Evan. So everything's looking beautiful. Just we drop A's and O's in front of oxide. Okay, so just a little tiny thing there. Okay, but it looks good. Yeah. So you use mono when there's one of them and when it's the second element. So when it's one of them and it's the first element, you'll see we don't have it here or here or here. When there's one of the first element, we don't use mono, but when there's one of the second element, we do use mono. So like if there wasn't a number two, you have to put mono, that's right. Yeah. Thank you. Awesome. Yay. Thank you. Pardon me? You don't have to hold on to them, you can do whatever, but if you lose it and I have not written it down, it's nice to sort of like have it there. Like, perfect. Well, it's just if I forget to write it down, because for example, Kai and I didn't write down his quiz number 3 for whatever reason, because like my brain, I don't know, I just didn't write it down. But you know, it's up to you. I have everything written down so far for you, so you're good up to quiz number 5. So yeah, you can do whatever you want with them. Excellent. I will be right over. I'm just going to finish marking this one. Okay, there we go. Stephen and Ella. So Ella just this we don't change the ending of the first word and we drop A's before O's, but other than that, it's looking great. Okay. Yeah. Quiz 5 for I will be with you in a second. I just have to go chat with Izzy. Okay. Thank you, Nima. A drops before the O. Not a big deal. So we do put mono on the second word. You can take one with you if you want and work on it at home. Oh, okay. Yeah, so you can just do it right now if you want. Yeah. You're welcome. See you later. What's that? What happened?
I accidentally took my fiance's laptop to school.
Oops.
I left my laptop at home, and he works from home, and I took his laptop.
Oh dear. Oh well, what can you do? We should be able to fit through this way if you want to. We're behind. Yeah. Anita, I'm just gonna go on break. I'm gonna go on break. I'll be back. sinus. All right, let's see what we got. Yeah. I think that sounds good. Yeah. Perfect. Yeah. Yeah, yesterday was a little crazy. Yeah. But yeah, I'll see you flex time tomorrow and we'll get through some of that. And if you want to take a look at that test as well, we can do that. Yeah. Cool. Perfect. Perfect. Sure. Yeah. Thank you.